is real, it's the next episode.
Hello, welcome back to episode 10 of the 18650 Mountain. We're going to carry on with Project Jehu and go on to concept 3. And in this concept, we're going to use the principle of K.I.S.S. Keep it simple, stupid. This is my favorite thing about being an engineer, is the fact that you can come up with various ideas and sometimes they come quite unexpectedly. At this point in the day, I was taking some packs apart and I was generally thinking about products that were complicated at the time because I wasn't too happy about the other two concepts that we came up with, and I wanted something that was still very simple. And I thought, what products have come out and since then have been very simplified and taken the world by storm? Well, mobile phone technology is one. I used to own a BlackBerry, and then I came across an Apple iPhone very late, which was iPhone 4 in my case, and I couldn't believe that it did everything the BlackBerry could do but better, and the way it did it was through software alone. And that's something that even Tesla have looked at in their cabin design. Just a very straightforward touchscreen, very few buttons that are minimal, and the whole car can be controlled by software, which can be updated automatically. Well, we need to apply this principle to concept 3, I feel. It's all very nice having a visual system that you can see and the batteries are moving through the phases, but do we really need the batteries to move through the different phases? Think about all the motors, the stepper motors, the sensors, the tweaking, the fiddling. That's not what we're doing this project for. We're doing this project so that we can process the batteries as quick as we can. Why not allow the phases to go through each of the batteries? So my idea, concept 3, is called the grid, and it will be basically a simple box where you can put the batteries in and it will go through each of the batteries, charge them, discharge them and recharge them, and store that data on a display for you to go through and note by hand. Let's show you the CAD work. Well, I hope you enjoyed that CAD assembly. I had actually modeled all the separate components individually, and what you saw there was just the assembly of all those components. This is it. This is what we've got here as the concept. It's just a simple box. And if I go through each of the layers from the bottom to the top and explain how they all work. So right at the bottom, we've got the actual box that will hold all the electronic gubbins. This would probably have a few Arduinos in there. Possibly a Raspberry Pi, I don't know. On the left side here, what's sticking out is actually, I call the writing station. So you'll be presented with all the figures that you need to transfer here by pen. Yes, I know it's not fully automated, but this will always be the stickler for me, trying to get that bit to be fully automated. But we could look at maybe upgrading it with some sort of printer head here. But at this stage, just to keep this thing simple again, it's better to just look at the numbers there, look at the capacity, and annotate the figures on the battery itself. Just above it, this grey section here, this is actually the 18650 grid. There'll be lots of little pockets in there where you can plonk the batteries down. And above that, finally, is the actual lid. That you would close the box in, and it would kind of take care of the 3 phases for each of the batteries. Now let's open the lid up and see what we got inside. So the construction is very simple. The actual grey box, the grid, will have 10 columns and 5 rows, all noted with a 0 to 9 and an A to F. This means that it can hold up to 60 batteries. The reason I've decided to use 60 is because it's about the right size box that you can create for 60 batteries, which will allow you to print this in most 3D printers. The lid itself and the terminals are constructed of M4 button head screws. So at the very bottom here, if I zoom in there, you can actually see one of the screws right at the bottom on the beige area. And then you've got them over here as well. The process is very simple. Once you've filled the box full of batteries, now you don't have to use 60 batteries, you can use whatever batteries you want, as long as you start from A0 and fill up that whole bank there, and then move to the next one and so on. You cannot just put them randomly anywhere, so you have to start from one end and fill that row up and so on and so on. You could actually do a whole 6 down here and another 6 if you're doing it that way, because the idea is that these rows would be working independent of each other. So anyway, you close the lid like so, and on top of the lid are these RGB LEDs. Now we could propose a color cycle or a color code, where if it's red it's charging, where it's discharging it's amber, and where it's recharging it could be green, or if it's got an issue with the temperature then it's a flashing red or a flashing or a blue, I don't know. That was something that we could put in there. And talking about temperature, we'd also need temperature sensors, 60 temperature sensors for individual batteries, and they could be tied into the bottom terminal so that it will pick up the temperature. Once you filled up, you close the lid. All you do is you press the red button in the middle, the software will start running, and it would go through a column at a time. So all of these would light up consecutively in red, and as they charge, discharge and recharge, they would progress to the next one and so on. Now what I've annotated here is you can see that there's a random amount of some that have charged and some that have taken longer because maybe it's a dead battery, or maybe it's just taken too long to charge and discharge. So they are LEDs at the top, which allows you to quickly glance at the unit and see how far you are along that cycle. Once you're finished, you open the lid up and you can begin removing the batteries. Doesn't matter what order you are doing them, but this will have the capacity in order of A0 right down to F9. So you'd probably want to start from A0 and work your way to the last one, and then you would write them down, put them into storage. So one thing I didn't think about is it'd be kind of handy to have a voltmeter on the writing station, so that you could then come back to when you need to check for internal resistance. You can just use that as opposed to just keep using probes all the time. So let's have a look at the gubbins box right at the bottom here. We'll have to hide all of this stuff here. So you can see, just for representation, I've just put 3 Arduino Nanos and a Raspberry Pi, just so that you can see also the scale of it. There would be some internal fans either on one side, so we could have one here and one here, sucking air in from that end, and another one on this end and that end, blowing air out, just so that there's a cross stream of air across the boards. There will have to be some sort of constant resistor in there, 1 amp, to take up 1 amp. So we put our top lid on and we put our terminals on. That's how it would be assembled. If you put the grid back on now, if you have a look at the grid independently. So the grid again is designed to be very simple in manufacture. It's got a flat bottom, filleted edges on the inside, so it's easy to slip a battery in. I have only toleranced about 0.4 of a millimeter bigger than the battery, but I think we should make it a little bit more bigger than 0.4, so that we don't need to clean the batteries up too much until they've all been tested. And then obviously you've got the hinge bit with not a crazy overhang, so it's easy for it to be printed. Now I think this is just a concept, but the only thing that this needs to be a bit more hollow, and I think it would be better off to be almost skeletal in construction, so that you can have a series of fans across the front and the side that would keep hopefully the batteries nice and cool. Maybe a fan on the front, 3 fans on the front sucking air in, and 3 fans on the back also sucking air in, so that the air has only got one way to go, which is out through there. So the lid, again, very similar to the grid to hold the batteries. It's a very easy 3D printable part. It will go on the bed like this. The holes will be pre-printed out. And this is actually in 2 parts. So you got the top lid bit, and we're looking at this upside down, and you got the bottom lid bit that would hold the screws in place. Let's see if I can make one of these invisible, so you can see how this one. So here you can see stepped and staggered. These obviously will have nuts on each one, so they're captive in place. And similar to the other side as well, where we've got the negative terminals. So pros and cons about this concept. Well, so far the pros, I feel, let's just bring back the lid. So yeah, pros and cons. The first obvious one is that there's actually no moving parts. The only part that we have that is moving is clearly the hinge where the lid moves, and that's about it. Because this has the same effect as an incubator, you can just fill up this box, close the lid, press go, and you can pretty much leave this unattended, because you'll know that if it overheats, won't do that one, get on with the next one, and so on. And it's easily manufacturable. It's, apart from the electronics, the whole box and the components are easy to 3D print, and the electronics is I think affordable. Arduino Nanos are not too expensive. A Raspberry Pi you can pick up fairly cheaply. You can pick up the thermosensors as well. I would say that's pretty much an affordable concept that is easily made. The cons are, well, mainly for me, it will be doing the electronics. The electronics will be something I will clearly struggle in. And I would very much invite anyone out there who's seen this video to jump on board if they think that this is something that they would love to do. It's a challenge for them. Then I would absolutely love that support, and I'll quite happily do all the mechanical stuff and learn some of the electronics that you guys are doing to enable this concept. But then again, I'm not a very good devil's advocate for these sort of concepts. So I'd love to hear what you guys think, and let me know your thoughts about some other negatives that I haven't thought of, but also where we could make improvements in this concept. Well, thank you for joining me on episode 10 of the 18650 Mountain. Concept 3 for Project Jehu I feel is probably the simplest idea that anyone can come up with. It's a straightforward construction. The downside is the electronics. This project is open source and it will require someone with the expertise to come in, jump on board and give me that little bit of help that I need. Talking about open source, there is another person that I like to give a big shout out to, and that's Russ at RWG Research. Now, I discovered Russ almost a year and a half ago when he was building his first Delta 3D printer, and since then his projects and his ideas and the different things that he's been coming up with has been really entertaining, and he's another inspiration of mine for having to start my own channel. Currently he's working on an oversized Delta printer, and I have to say I'm so excited. I can't wait to see the end of that result, and his thoughts and his input on something like that has just been amazing, and slightly jealous of the fact that he's got so much resources out there that he can get his hands on. But at the end of the day, I wish you the best because he's just amazing. Russ, like me, he's also dependent on open source research, and he appreciates the community out there that come in and give him some input into his channel. And I think we are both like-minded individuals in the sense that we trying to build a community whereby we can all do things together. He's left a very good footnote on his YouTube channel, and I'll read it out because I think it's very nice, and I think the sentiment there should make sense to everybody as part of this community. We are all in this together. Help and be helped, learn and be learned, love and be loved, and that's the way to be. So I can't say any better than that. Well done, Russ. Feel free to subscribe to his channel. I'll link it somewhere on this shot, and it'll be in my description as well. Well, as always, thank you very much again. Feel free to subscribe, like this video, and I'll see you on the next one.